This problem starts out by telling you that you have a bar, and it doesn't say how long it is or how big it is, but the first thing it tells you is that it balances at a certain place, right? So if you stuck a pencil there, it would balance. And it gives you the distance from this balance point to one end of the bar. So I'm going to call that A. Now we know that if something balances at a certain point, that means that that point is its center of mass. So what they're really telling you is that the center of mass is that distance A away from the end of the bar. And now they're going to tell you that they take the same bar and they're going to hang something from this end. All right, so we still have this place over here that we know is the center of mass. We have a mass hanging here. I'm going to call that little m. And it says that the balance point moves from here closer to this end of the bar, which makes sense. And it says that it moves a certain distance, which I'll call b. So let's say that here, this is where it's going to balance now. That's the new balance place. And it gives you A and B, and it gives you this mass, and it asks you to calculate the mass of the bar. So we're going to do that using force balancing and torque balancing. So here's another picture of the bar, and now I'm going to draw forces. We have a force from the hanging mass. I'm going to call that little mg, and it's right here on the end of the bar. We have the force from the weight of the bar itself, and that's going to be at the center of mass here, and I'm going to call that big mg. Then we have this balancing place here, and at the balancing place, we have a force upward. I'm just going to call that F. And that's the whatever's holding up the bar, holding it up. So there's our three forces. We can also, well, the first thing we can do is we can write a force balancing equation. So for the force balancing equation, we just look at our torque diagram as if it was a free body diagram. We add up all the forces and set it equal to 0. So the force upward minus mg with the big mg minus little mg is going to be equal to 0. But we see that that's not going to help us because we don't know this upward force, and we don't even want to know that upward force. So that's not going to help. We're going to have to go to torque balancing. Now to do torque balancing, you need to choose a center of rotation. And I already have an idea of what I want to choose for my center of rotation because I know I don't like this force F. So to get rid of that force out of my torque balancing equation, I'm going to put my center of rotation here so that this force has no lever arm, and that way it won't be in my torque equation and I won't have to deal with it. So that's going to be what I'm going to try. So I'm going to draw in my lever arms. That's my next step. So I start from my center of rotation that I've chosen, and I draw a lever arm out to this force. From what we figured out before, I know that this lever arm is, maybe we could call this lever arm number 1. It's going to be equal to B, that distance that they gave. Do you see it there? B. Then I'm going to do the lever arm for the other side, go from here to here. Maybe I could call that lever arm number 2. And I see from looking at this that what this is equal to is A minus B. The whole distance from here to here was A that they gave us in the beginning, and then so this piece over here has to be A minus B. Next, I'll look at the angles. Well, look, there's a nice right angle there, there's a nice right angle here, so I don't have to deal with anything difficult with angles. Yay! So I can go ahead and write my torque equation. I have two forces that have torques. One of them is pulling it counterclockwise, the other one's pulling it clockwise, so they need to be opposite signs. It doesn't matter which one's negative as long as one of them's negative. So I'm going to do this one first. That's R number 1 times big MG. And then I'll do this one, minus R number 2 times little mg. And we know that has to be equal to 0. So that's an equation I can solve. R1 is B, so we have B, big mg, minus R2 is A minus B, times little mg. this has to be equal to 0. We know a and b, we know little m, we can calculate big M.